Hello again, and this video is at understanding a little bit more how to interpret the pixel values of the Landsat quality assessment band. And this is important for understanding how the cloud mask works when dealing with Landsat images. I will mainly talk about binary numbers and bitwise operators in JavaScript. This video is a little bit heavy on numbers, and it's not as practical as the other one. I have another video where I show you specifically what the function is doing, but here I enter a little bit more in detail about understanding functions and the operators in JavaScript. And you will learn what is this Landsat quality assessment 16-bit band, and you will learn from what is the left shift operator in JavaScript and what is a bitwise and operations in JavaScript. You will have some additional resources that I will put in the links below. So let's go to the data sets. And we have done this before. Go to imagery, explore Landsat, go to Landsat, go to tier 1, and let's go ahead and click on the code. Okay, and in the previous videos, I have shown you how to do masks, how to do Boolean if statements, and those things are important for understanding what is happening here, and also to understand how to reduce a image collection. Okay, but one of the things that I'm still missing to explain is all the things that are happening here, okay, which are these things and this thing over here. Okay, just to remind you what a function is in JavaScript. In JavaScript, a function is like a chunk of code or a block of code, let's call it, where you're gonna have like a set of instructions, okay? And usually when you are going to define the function, you just write function, the name that you're going to give that function. So you declare whatever you want that name to be. The people who wrote this decided to call it like this. And then you open parentheses, and within those parentheses, you're going to put the parameters that you're going to give to that function. And you give it whatever name you want. In this case, they have called it image. So after the parentheses, then we have these curly brackets, right, which go from here to here in this case. And within the curly brackets is that we're going to have what the function is for JavaScript. Okay, so here in the first line, we have this variable called cloud shadow bitmask. We decided to create this variable, and it's equal to this weird thing going on here. Okay, so what is happening here? We'll go there in 1 second. And I'll explain to you what is happening here. But what we need to do is actually learn why are we going to do that. And the reason is that we are going to do a mask, right? And we want to mask the clouds. And where do we get the information to mask the clouds? We're going to get that information from one of the bands from the Landsat. And one of the bands that have that information is this bit mask of quality assessment. Okay, and the information is in a binary code. And why did they do it this way? So, well, it's actually a very nice way of organizing the data. So to explain that, let me use an Excel spreadsheet. So you remember binary numbers, I hope. If not, let me before going there, show you something that I had here, which are binary numbers. So as you know, number 0 in binary, why It's marking that. So 0 in binary, 0 in binary is 0, 1 in binary is 1, 2 in binary is 1, 0, 3 in binary. So binary is the idea of trying to represent something, some number, right, with a code that it's a combination of true and false, right, or 0 and 1, right? So we're trying to represent a number like 4 with only numbers that are 0 or 1s, 0 or 1s, and you can get the idea of how this is happening, right? Here I'm just going up, and you can see what what a decimal value like 8 is represented in binary, right? So we need 4 digits here in binary to represent 8, but we're only doing it with 1s and 0s. Okay, so imagine if we have a table like this, where we have a class that we want to, that we have in a pixel. And that class could be, it has water or it has clouds. And we have a table. And we're going to say, so that pixel has water. If it does not have water, then the value is 0. If it has water, we put 1. So let's say in this example that it actually has water. So we put the value 1 on this table. And we ask, does it have clouds? And if it doesn't have clouds, we put 0. And if it has a cloud, we put a 1. So in this case, we're going to say that the pixel had water, but it did not have clouds. So actually, see how easy it would be to create this code if we had a table. So what is the outcome of this values? Well, the outcome of these values would be a 2-bit number, right? Because we have two values here, 0 and 1, and this would be the case, right? So reading from right to left. So we have the first instance would be 1, and the second instance would be 0. So we have 1, 0 would be the value of that pixel. And if we see that pixel, we could say, well, it has water and it has no clouds. If we translated 0, 1 to a decimal value, then, it would be 1. And if you don't believe me, I just go ahead and do it. Sorry, this is not where we want to go. I want to go back to my binary code. So yeah, here we are. It was 0, 1, right? So, and then the decimal value is 1, okay? So let's go again and give an example of if we had water and if we had clouds, then that would be 1. So let's say that pixel actually has water and it has cloud. So our outcome would be 1, 1. And what would be that in decimal values? Then that would be 3, okay? And again, I'm just gonna show you that that's the case. So decimal value 3, or rather it has water and it has clouds. So decimal value would be 3. Okay, so not only we can give situations of the value of the pixel being yes or no, but we can also represent some gradients, and this we will see it in the Landsat image. So we will have situations like it would be 4 different categories: no clouds, low clouds, medium amount of clouds, or a lot of clouds. So, and we can give codes like this. So now instead of being 2 bits, we have to do 3 bits. So let me go back and do a similar situation. Let me zoom a little bit out so I can invent something here. And let's say we had no water, but we had a medium amount of clouds. Okay, so that number will be let's give it this value. All right, so then what would that be? So the result would be 1, 0, 0, right? Because it would be no water. So that's the first one is 0. And and it has a medium amount of cloud, so that would be 100. And what would be that in decimal values? So let me go ahead and show you here. So 100 would be the value 4. Okay, so we go here, and that would be the value 4. Okay, and that will be the way that we will see the data, that the computer sees the data, right? It sees the data in binary numbers, and this is the way that the data is organized actually in the bands of the Landsat quality band. And there's more information that you can read in this document for Landsat. And again, you can see that all the different values in decimal values that could mean from the different bit combinations. But the way that Google Earth Engine has it is with this bitwise combinations, and it can tell you here. So see the first, the first meaning the value 0, right? Because we're talking about JavaScript, so we start counting from 0. So it would be 0, 1, 2, 3, and all the way. So the first value is fill, or if it's clear, if it's water, if it has cloud shadow, if it has snow, cloud, and you can see. Okay, so let's go to the code, and you can see in the function that here we have something like a 3 and a 5, and they put it here in the notation very nicely. Bits 3 and 5 are cloud, shadow, and cloud, and you can see it here in the band. So bit 3 is cloud shadow, and bit 5 it's cloud. Okay, but what is this thing that we have here? So okay, so that thing that we have here is what I told you in the presentation, right? Is the left shift operator in JavaScript. And to show you a bit how does that work, think about like shifting the zeros in the binary code, actually. So if we go to the binary code, for instance, and I had the value 1, right? And I say shifted one column to the left, then the decimal value for that would be 2. If I move it 2 columns to the left, then the decimal value would be 4, and you can see the process, right? So what in a certain way the code is doing in this code, let's get to the code. Let me close this, I don't need that anymore. It's saying, well, analyze the third bit in a certain way, the third bit, and in this case the 5th one. But you know, this is something that in JavaScript, as I said, is the left shift operator in JavaScript, and we can actually do it in the inspector, for instance. Here I'm using Firefox here, and for instance, let me see if I can write a little code here so you can see. If x equals, I can even use this right now that I copy pasted. That's perfect. And then you can see the results. So and it's the same thing as I had there before, so I could actually go one by one. So that should be 2 exactly, that should be 4, right? So you can see that it's a process of shifting the values in the binary. Okay, so let's go back to the code. And how do we get there? Here. Okay, so yeah, so here I'm doing that left shift, and I'm just calling it, you know, that this left shift of 3 and of 5, I'm gonna add some number, some name cloud shadow bit mask and clouds bit mask, again because on the band 3 means cloud shadow and 5 means cloud. Okay, good. All right, so now we're going to apply a BitwiseAND using this left shift And as well, we're going to use a BitwiseAND on using this left shift F5 in the cloud bit mask that we called cloud bits mask. Okay, and what is a BitwiseAND? Well, let me show you what is a BitwiseAND. And for that, I have here a table from w3schools.com, and sort of similar to, you know, when we're doing the Boolean if with the rasters, right? So see here, this is a case where you have this number and this number, and you can see there's no similarity, right? And if you have this number and this number, the only location where we have similarity is here in the first value here. And you can see the examples where you are going to see some both have ones, then you're going to have a result of 1 in the resulting value. So we're doing this bitwise AND, and we are also then doing the Boolean that we're saying if it's equals to 0, then that's good, right? Because it does not have clouds, right? Or it does not have shadow. So those things are good. Those are the values that we want. The rest we want to mask, okay? Right? So that's why then we're going to apply to the image the mask. And this is all within, we're creating this function, right? And where are we going to apply that function? We're going to apply that function to the image collection that you decided to select a date for the year 2016. And you're going to apply that function using this, we'll call it method called .map. .map is very important because it's the way that Google Earth Engine does loops, but it doesn't do it in your side. It does it in the cloud. Okay, so there's certain things that you need to do it in the cloud because we're dealing with a lot of information. So this is something that I will explain with more detail later on, but understand that if we're going to do such a function on so much data, then it needs to be done in the server and not in your computer. Okay, so here it's applying the function, and then that results in a data set that it's masking all the clouds and the shadows. So I should say it's masking the clouds and the shadows, right? And you can see the AND. So I hope this video helped you understand how to use binary numbers, especially for masking data in Landsat images.